Hello, this is Dr. Brown, and this unit we're going to be looking into sets and Venn diagrams. It's on page 319 to 328 in your textbook. I recommend that you look at the notes I've sent you and take notes on my notes and work along with me as we work a number of problems. We're going to be looking at a lot of definitions here. I'm sure you've heard of sets before. Obviously, it's natural for us to classify items into groups or sets and consider how these sets overlap with each other. We can use these sets to understand relationships between groups and to analyze survey data. A set is a collection of distinct objects called elements of the set. A set can be defined by describing the contents or by listing the elements of the set enclosed in curly brackets, like that. Example. Some examples of sets defined by describing the contents. The set of all even numbers. The set of all books written about travel to Chile. Some of the examples of sets defined by listing the elements of the set are 1, 3, 9, and 12, or you could list a bunch of colors as shown here. There's some notation that we use. We will use a variable to represent a set to make it easier to refer to that set later. It could be called A, B, C, or anything you want to. The symbol that looks sort of like an E means is an element of. A set that contains no elements is called the empty set, and it's also notated like this, like a 0. Okay, that set A, B, the numbers 1, 2, 3, and 4. To notate that 2 is an element of the set, we just simply write 2 is an element of A. Subsets. A subset of a set is another set that contains only elements from the set A, but may not contain all the elements. If B is a subset of A, we write B sort of like contain, but like this, in A. And a proper subset is a subset that is not identical to the original set. It contains fewer elements. So if B is a proper subset of A, we write B with something looks like a C and A. That just means B is a subset of A. Consider these 3 sets. A is a set of all even numbers. B is 2, 4, and 6. And C is 2, 3, 4, and 6. Here, B is contained in A, or is a subset of A, since every element of B is an even number, so it is an element of A. More formally, we could say that B is an element of A, since if X is a number that is in B, then X is in A. It's also true that B is a subset of C, because 2, 4, and 6 are the elements of B, and it's obviously a subset of C. Now, C is not a subset of A, since C contains an element 3 which is an odd number. It's not even, so it's not contained in A. I think all of this is pretty straightforward. Example 4. Suppose a set contains the plays Much Ado About Nothing, Macbeth, and A Midsummer's Night Dream. What is the largest set that they might be a subset of? There are a lot of answers to this. It could be a set of plays by Shakespeare, which were quite many. It's also a subset of all plays ever written, and also a subset of all British literature. And if you want to get even bigger, you could say a subset of everything ever written. Now we got some more definitions: union, intersection, and complement. The union of two sets contains all the elements contained in either set or both sets. Basically, you're taking all the elements in both sets and putting them together in one set. More formally, and then this is notated by, and I know you've seen this before, A union of B. And if the element X is in A union B, if X is contained in the set A, or if X is contained in set B, or it could be in both. No, the intersection of two sets contains only the elements that are in both sets. They got to be common to both sets. And it's notated like this. A intersection would be. More formally, if X is contained in A intersected with B, if X is in A and also X is in B. It's got to be in both. Now, the complement of a set contains everything that is not in the set. And it's notated usually in this course as A complement. Sometimes it's written like A prime, or sometimes with a little wiggly symbol, but we're going to be using A complement in this course. Example 5, consider the sets A, red, green, and blue, and B, red, yellow, and orange, and C, red, orange, yellow, green, blue, and purple. We want to find A union of B, A intersected with B, and A complement intersected with C. So let's do this on the other page. Here are the sets we were talking about. The union A union B has got to be all the elements that are in both. So we're going to have red, green, and blue, and then we look at the elements in B. It's already got a red, so we're going to keep the red, obviously, but we're going to pick up yellow and orange. So A union of B is just basically all the elements that are in A and B. And of course, we only listed red once. Now, the intersection contains all the elements that are in both A and B. So you need to just look at the sets. And you got red in both. And you don't have green in both. You don't have blue in both. So the intersection of the sets is red. Now, to find A complement intersected with C, we first write out A complement. Well, A complement is going to be all the other colors that are not red, green, and blue. So we start picking those up, and we get yellow, orange, and purple. Notice blue, green are not in A complement. So A complement then is going to be orange, yellow, and purple. So the intersection of A complement and C is going to be, well, if you look at A complement, you got orange, yellow, and blue. You got orange, yellow, and blue, and C, but you don't have, but you have red, which A complement doesn't have, and green, which A complement doesn't have, and blue, which A complement doesn't have. So A complement intersection with C is going to be orange, yellow, and purple. Now, a universal set is a set that contains all the elements that we're interested in. This would have to be defined by the particular problem or the context that we're talking about. A complement is relative to the universal set, so A complement contains all the elements in the universal set that are not in A. For instance, suppose the universal set was this rectangle, and you represented A by the circle, then A complement would be everything else in the universal set that's not in A. So here is A complement. Example, if we're discussing searching for books, a universal set might be all the books in the library. If we were grouping your Facebook friends, a universal set would be all your Facebook friends. If you're working with a set of numbers, a universal set might be all whole numbers, all integers, or all real numbers. Could also be all negative numbers. Example 7, suppose the universal set is all whole numbers from 1 to 9. And if A is 1, 2, and 4, then A complement would be all the other numbers that are in the universal set, but not including 1, 2, and 4. So that would be 3. We'll skip 4 and 1, of course, and then pick up all the rest of them all the way to 9, 5, 6, 7, 8, and 9. So this is A complement. I suggest you all do this as I'm doing it. Pause the video, take notes, and see if you can produce the same answers I'm producing here. As we saw earlier with the expression A complement intersecting with C, set operations can be grouped together. Grouping symbols can be used like they are with arithmetic to force an order of operations. Okay, another example. Suppose H is a set cat, dog, rabbit, mouse. Elf is dog, cow, duck, pig, rabbit. And set W is duck, rabbit, deer, frog, and mouse. We want to find the intersection of H and F and union with W, and then find the intersection of H and intersected with F, of the union of F and W, and then finally find the intersection of the intersection of H and F complement intersected with W. So let's slow down and take a look at this. Okay, I've written down the three sets we're talking about. And first of all, we want to find H intersected with F, union with W. So let's start with the intersection of H and F. If you look at H and F, we want to find the common elements. Obviously, we both have dogs and both have rabbits, but no other common elements. So the intersection of H and F is dog and rabbit. Now we want to union that with W. So to the dog and the rabbit, we're going to add a duck. We already have a rabbit, a deer, a frog, and a mouse. So this is part A, answer. Now, suppose we wanted to find the intersection of H intersected with the union of F and W. So let's start with the union of F and W. And looking at F and W, we want to take the union, and that's going to be a dog, a cow, a rabbit, a duck, a pig, and then we're going to add a deer, a frog, and a mouse. And now we want to intersect that with H. And let me erase a little bit here so we can see what we have. Okay. So we have the union of F and W, which we want to intersect with H. And here is H. And so the common elements are a dog, a rabbit, and a mouse. There's no frog, there's no deer, there's no pig, there's no duck, and so that's the answer. You have to sort of write this out and sort of mark things off in order to do this. Now we're going to show things about Venn diagrams in a little bit that will make it a little easier to do some of this. Now the last one is to find the complement of the intersection of H and F and then intersect that with W. So let's start with the intersection of H and F, which is common elements are dog and rabbit. Now, the way that I have generally done this is now take the complement of H intersected with F, and that's basically everything that's not in H intersected with F. Now H intersected with F is dog and rabbit. So all the other animals outside of that set would be the complement. And if you look at it very carefully and list them, you got cat, mouse, cow, duck, pig, deer, and frog. That's all the other animals listed here, all the others in the universal set besides dog and rabbit. And so now if you take and intersect that with W, you find that the common elements are duck, deer, frog, and mouse. You can also note that this is also all the elements of W that were not in the intersection of H and F. I'm sure you all need to work a few of these problems, write them down, be careful with your notation, and look at the elements and count it, make sure you don't miss anything. Now we're going to get into Venn diagrams, which I think you'll find are fairly easy to understand. Venn diagrams were invented or introduced by a guy named John Venn in 1880 and he used overlapping circles, building on similar ideas used by Leonard Euler in the 18th century. They're called Venn diagrams. You represent each set you're trying to analyze by a circle, usually drawn inside of a containing box representing the universal set. Overlapping areas indicate elements common to both sets. Now, Venn diagrams can illustrate the interaction of 2 or 3 sets. Here is a very simple example of the yellow. Well, you have 2 circles, A and B, and they're overlapping. And we're going to depict what the A union of B would be. Well, this is A, this is B. The union would be what we've outlined in red here. So basically, this would be A union of B, everything that's in A and B. Now, to depict A intersection would be, it would be the overlapping part, or the stuff here that's outlined in heavy red ink here. This would be A intersected with B. Now, we want to do A complement intersected with B. Well, A is this. Its complement would be everything outside of A complement, including the areas out here in white. And if you intersect that with B, the common areas would be what we see with the heavy red. Another example, we want to use a Venn diagram to illustrate H intersected with F complement intersected with W. So here we have H, W, and F. First of all, let's identify the intersection of H and F. And again, that's this heavy red indicated here. And next, on the next page, I showed H intersected with F complement, and that would be all the squiggly lines you see here, everything outside of the red football here. And in fact, that would even include stuff in the universal set here. But then we want to intersect that with W. So all the squiggly lines intersected with the W circle would be what I've outlined here in black. That would be H intersected with F complement intersected with W. And in a nicer picture, I've got that outlined in red. So this red set here is H intersected with F, complement intersected with W. Suppose, here, let's work an example that shows how to use a Venn diagram. Survey asks 200 people, what beverage do you drink in the morning, and offers choices. Tea only, coffee only, both coffee and tea. These are the questions that were answered. 20 people report tea only, 80 report coffee only, 40 report both. How many people drank tea in the morning? How many people drank neither tea or coffee? We can use a Venn diagram to do this. We have 20 report tea only, 80 report coffee only, 40 report both. So here we have identified the overlapping area where both drink, the person drinks coffee and tea, and then the light blue area over here, there are 20 that drank tea only, and then over here the 80 who drank coffee only. Now, we were asked how many people drank neither tea or coffee. Well, since there are 200 in the universal set, and we got 140 total here, there must be 60 that drank neither. And the other question, how many people, well, the question was only how many people drank neither tea or coffee. Now, we have a third example here that we will work. 50 students were surveyed and asked if they were taking a social science, humanities, or natural science course the next quarter. And here's what they answered, and I won't repeat all of these. Question is, how many students are only taking a social science course? And we should be able to do this by using the Venn diagram. First, look at the information. 21 were taking a social science course. So this circle here for social science is going to have 21. The one for humanities is going to have 26 in it, and the one for natural science is going to have 19. And you need to try to fill in everything else by the information. An important thing is it says 3, we're going to be taking all 3. Well, that would be represented by where all 3 circles intersect. So we would put 3 there. And now let's make use of the other information. 9 were taking social science and humanities. So that would be this area here. So if that's 9 total, then there must be 6 here, because putting a 6 in the light green area would add up to the 3 that are taking all 3 courses and give you 9. 7 were taking social science and natural science. So that would make this 4, because this little football would represent those that are taking both social science and natural science, and it says it's 7. And 10 were taking humanities and natural science. So there has to be 7 here to make the humanities and natural science add up to 10. So now, how many were only taking social science? Well, that would be here. And to figure that out, we know that a whole circle, the circle for social science is 21. And the other areas are 6, 3, and 4. So that's 13. That means 8 are only taking social science. So that is the lecture on Venn diagrams and sets. And I urge you to start doing the homework and ask me any questions, and also attend the Zoom video conferences.